66 million years ago, a Tuesday morning, the sky splits open. For 1/10,000th of a second, a rock from space touches the ground, and the Earth's crust explodes. Every dinosaur on the planet has 10 hours to live. It's a normal day on Earth. A Tyrannosaurus rex is hunting in what will one day be Montana. Triceratops herds graze across floodplains. Pteranodons soar over an inland sea. The dinosaurs have ruled this planet for 165 million years. Humans won't exist for another 65 million. Then, without warning, the sky ignites, but not everywhere. Not yet. In the Yucatan Peninsula, modern-day Mexico, something appears. An asteroid, 6 miles wide, moving at 45,000 miles per hour. It punches through the atmosphere in less than 2 seconds. Air doesn't have time to move out of the way. It compresses, heats. The entire sky above the impact site turns into a plasma fireball hotter than the surface of the sun. And it hits. The asteroid doesn't slow down, doesn't break apart. It vaporizes the ground on contact. In one instant, faster than a heartbeat, the object that ended the dinosaurs ceases to exist, and the destruction begins. The asteroid impacts with the energy of 10 billion Hiroshima bombs. The Earth's crust, solid rock 30 miles deep, behaves like a liquid. A shockwave races outward at thousands of miles per hour. Rock vaporizes, then liquidizes, then explodes upward in a column 20 miles high. A crater is already forming, but this isn't like any crater you've seen. The ground rebounds. Imagine dropping a stone into water and watching the splash freeze midair. That's what's happening, except with molten rock. A mountain of liquefied crust rises from the center of the impact site. 15 miles tall, it collapses seconds later. The crater is now 60 miles wide and still growing. The shockwave has traveled 600 miles. Everything within that radius is already gone. Forests, oceans, mountains, erased. But the dinosaurs thousands of miles away don't know yet. They can't. The destruction is moving faster than sound. T plus 3 minutes. Debris ejected from the crater begins reaching space. Trillions of tons of vaporized rock, molten glass, superheated dust. Some of it escapes Earth's gravity entirely, but most of it will come back down. And when it does, the entire planet will burn. T plus 15 minutes. The first earthquakes hit. Magnitude 10, maybe 11. There is no magnitude 11 on the Richter scale. This creates one. Fault lines around the world snap. Mountains collapse. In the Gulf of Mexico, the ocean floor splits open. Mega tsunamis, walls of water over a mile high, race outward in all directions. They'll strike the coastlines of North and South America within the hour. T plus 1 hour. The debris ejected into space begins re-entering the atmosphere. All of it, at once, across the entire planet. Imagine a meteor shower. Now imagine it's not a few dozen meteors. It's billions, trillions. The sky becomes a grid of fire. Superheated particles rain down at terminal velocity. Friction with the atmosphere heats the air to over 800 degrees Fahrenheit. Everywhere, the entire surface of the Earth is now inside an oven. T plus 2 hours. Forests ignite, not from impact, from radiant heat. Every tree, every plant, every creature exposed to open air, burning. This is a global firestorm. 70% of the planet's forests are on fire simultaneously. Dinosaurs that survived the shockwave are now suffocating, cooking, fleeing into rivers that are boiling. There is nowhere to go. T plus 10 hours. The fires are still raging, but now a new killer arrives. Darkness. Trillions of tons of ash, soot, and vaporized rock are suspended in the atmosphere. They block out the sun completely. The temperature drops, not slowly. In weeks, the global temperature plummets by 50 degrees Fahrenheit. Photosynthesis stops. Plants die. Herbivores starve. Carnivores starve. The food chain collapses from the bottom up. This is called impact winter. It will last for decades. So why did anything survive? Why are we here? The answer is size and luck. Dinosaurs were large. They needed massive amounts of food. When the plants died, the big herbivores died. When the herbivores died, the big carnivores died. Anything over 50 pounds? Gone. But small mammals, creatures the size of rats and shrews, had an advantage. They lived underground, sheltered from the firestorm, sheltered from the heat. They could survive on insects, seeds, and carrion. They didn't need much. And when the world went dark, they waited. Birds survived too, the ancestors of modern chickens, ducks, and sparrows. Small, adaptable, able to eat seeds buried in the ash. Crocodiles and turtles survived. Cold-blooded, slow metabolism, able to go months without food. The ocean's deep-sea creatures survived. The impact winter didn't reach them. But the rulers of the earth, the giants, the apex predators that had dominated for 165 million years, they had 10 hours, and then they were gone. 75% of all species on Earth went extinct. It took 10 million years for biodiversity to recover. But the world that emerged was unrecognizable. The age of reptiles was over. The age of mammals had begun. In the ashes, small creatures evolved, diversified, grew. 50 million years later, primates appeared. 15 million years after that, early hominids. And eventually, you. If that asteroid had been 5 minutes early or late, it would have hit the ocean. The impact would have been devastating, but not extinction level. Dinosaurs might still rule the Earth, and humans would never exist. Every person alive today owes their existence to a rock, a 6-mile-wide chunk of stone and metal that happened to arrive at exactly the right place, at exactly the right time, to end one world and begin another.